Hey YouTube fam, welcome back to another episode of Code with Annie. This is a continuation from the last video, that is the part one of abstraction. So we're going to continue looking at abstraction and through the lens of interfaces this time. Last time we discussed on abstract classes. Today I'm going to tell you how interfaces help in abstracting out certain implementations in Java. So interfaces is yet another concept in Java which basically helps you define abstract methods. So let's say we have an interface. Um, for shape, which is an abstract class, right? Let's try to make this shape class as an interface. So if I say interface shape, it becomes an interface automatically. See, you can see the simple change, but there is some problem with this as soon as we change it here. The problem is the implementation, right? There is no implementation of interface because the way we implement interface in Java is slightly different from the way we extend an abstract class. So classes can be extended, interfaces can be implemented. So there is a keyword difference with the way we deal with abstract classes and interfaces. So let's go to rectangle. So rectangle extend shape is wrong. So when you have an interface, it becomes rectangle implements shape. Same way, circle implements shape. So you have rectangle and circle, and both of them are implementing shape interface, and there is a method within the shape interface, which is public abstract double find data. Now you observe that public and abstract are grayed out. The reason is you don't have to specify methods as abstract within the interface because the methods by default are usually abstract. So you don't have to say public abstract. By default, they are public and by default, they're abstract. So you can remove these two keywords from here. It just double find area. Still, there seems to be some problem. So let's look at that. Find areas implementation is in circle and this one. What is the related problem here? Oh, it's in the main class. So the way we access in main, we're saying shapes.find area, right? So the interface is not public. So let's go ahead and make that public and we should solve it. Public interface shape, find area, and voila, we have the abstract class become an interface right in front of our eyes. So you can have a quick question here, like, why do we have two ways to make things abstract? What is the purpose of having an interface when you already have abstract classes, which in fact are better because an abstract class can also have non-abstract methods within it with some default implementation of its own. So why should we have interfaces? In fact, from Java 8, even interfaces can have default implementations. So it's a default string get name. I can simply say return, hey there, this is Annie. See? So even interfaces support implementation methods, non-abstract methods. And even in Java 9, you also have private methods that you can define within the interfaces. As I mentioned, by default interfaces are public, but you can also have a private keyword for the interface, but you should have an implementation of it. Private methods in interface should definitely have a body because for obvious reasons, you can't have a private method. Access modifiers is a different topic, which I'll talk about. But for this video, I'm just telling you that whenever you define something as private, it should remain within the class or interface which is having it. It should not be exposed to anyone outside. Even the ones who implement this interface or even the ones who extend a class should never have access to the privately defined variables and behaviors because that's private basically. So in this case, we can't have an abstract private method because you should definitely have an implementation defined right within shape. So we'll just remove the private method for now. But what I'm trying to explain is we do have certain additions to interfaces with incremental Java versions, and that is narrowing the gap between abstract classes and interfaces. So why should you have both of them? For one simple reason. Let's say there is another interface. Okay, you can choose an interface. I can call it, let's say, just another interface. Okay. Now, in this one, I can have another method implementation. Let's say simply for the sake of writing it, public string get shape name. Okay, that's it. I don't have to define public, obviously, I forgot. It's an interface. So you just have this. Now I can have my rectangle and circle classes implement this one with just a comma separated definition. I can say just another interface. Immediately it will throw an error because there is a method within just another interface which I haven't implemented. So let's implement that, which is get name, or sorry, get shape name, I think. 1 minute. And I'm going to say this is rectangle. Okay. Likewise for circle as well, I can say just another interface. Immediately it'll throw an error. Let's say implement method, get shape name, and I'll say circle. So as you can see, I can keep adding interfaces with comma separated values, and everything that the class implements will have the behavior defined as well automatically. So this is one key aspect of interfaces which abstract classes cannot do, because in Java, you don't have multiple inheritance supported through classes. You can't have class circle extending shape if shape was a class, comma, just another interface, which is if it was also a class. Suppose these two were classes and you have an extends keyword here, it will automatically throw an error here because you cannot have extensions on two levels, or basically you can have not have multiple inheritance in Java. Only way you can do multiple inheritance is through interfaces like this. So that is the fundamental difference between interfaces and abstract classes, and one of the more driving factors to why interfaces are mainly used in many real world programming scenarios as well, in industries as well. You don't see abstract classes a lot, but you see a lot of interfaces, especially since the narrowing gap of interfaces and abstract classes, wherein you have default methods and private methods as well within interfaces. It is basically eliminating the usage of abstract classes almost. All right, with that being said, this is how an interface implements itself. Pardon me, I did not say implement itself. I'm saying this is how a class can implement an interface and also define the behavior that is just put inside the interface. So this method, this particular method getName that I've put here, right? This also can be accessed through your shape and shape one objects. Let me give you an example. Let's say out shape dot getName. All right. So if I run this, I'll get, hey there, this is Annie. At the same time, I can also have shape dot get dot shape, which is the other one. Mm, there's one more interface, right? Just another interface. Yeah. So I can say just another interface with just another interface equal to new rectangle. Absolutely fine. And I can say just another interface dot get shape name, and it'll say rectangle. Here we go. So you can understand the fundamental differences, right, as to why this is happening. Now I'll tell you one other important aspect of why we define objects like this instead of saying rectangle space rectangle or circle space circle. The reason is, let's say I have a method, okay? I have a method which accepts a shape object, okay? So in the real world, you will have one more layer of class, let's say something like area, okay? And this method, this particular class will say public class, sorry, um, double get area, okay, of shape, all right? So all I have to do is return shape dot find area. Also, I need the dimension, so I'm just going to pass dimension space dimension, and I'll say find area of dimension. That's it. Now, if you look at this class, it's a very simple class. It says that give me a shape object, give me the dimension, I'll find the area of the shape. Now, this is how you will feel when you get into a car and you just start it and it starts moving after you put it on drive mode. When you accelerate, it moves. This is exactly the scenario that I was talking about. So imagine this is you. You get into the car, you just start it, and you say just drive, and you drive it. You do not care. Shape.find area is invoking the rectangles area or it is invoking the circles area. You don't know that because it's abstracted behind the shape. So whichever instance of shape I pass here, for instance, I pass the rectangles instance, let's say shape space shape one, shape new rectangle. If I pass this shape object to this method and dimension, the area that is returned to me is the area of rectangle. When I pass the shape one, which is that of the circle, I'll get the area of the circle that's returned from here. But for the class area, it does not give any shit about what shape it is getting, what dimensions it is getting. It just calculates the area and returns me the area. So this is how abstraction works in Java. And this is one of the main reasons why the method, that is the instance creation, happens in this particular fashion. This is why it's advised to be created this way. All right. Imagine if I had created rectangle space rectangle, new rectangle. So I will be passing rectangle here because if I say rectangle shape, I'll give you the example and show you directly. So let's say, let's create the object for area as well, right? Area space area equal to new area. All right. Now I'll say I have this thing, right? So let's say area dot get area of shape, comma, what is a dimension, right? So dimension. Yeah, absolutely fine. There's no syntax error you see because shape is a subclass of, sorry, a rectangle is a subclass of shape, so you don't see any errors here. It's absolutely fine. There's a warning. It says return value is never used. That's okay. So if I come back to main class and instead of in get area, instead of shape, if I put rectangle space shape, all right. So if I go here, it will cry. Why? Because you cannot replace a superclass with a subclass, but you can replace the subclass with a superclass's name. What I'm trying to say is the superclass is your shape and subclass is your rectangle. So moment I keep this as rectangle, it's going to be a problem. But if I keep it as shape, which is going to be generic one and anybody can extend shape, it basically becomes more accommodating. So if I say shape, this can accept this instance. It can also accept shape one, which is a circle. So that is the advantage, the other advantage that I was talking about in the last video. And with this, we end this video on abstraction and how it is helping us with the help of interfaces and abstract classes, the differences in abstract and interface classes. There's one other concept which I'll talk in the next video, which is called as diamond problem in Java. So until then, I'll see you guys in the next video. Feel free to hit up the like button if you like this, subscribe if you haven't already, and bye-bye.